Maybe not. Testing. Okay, great. Maybe not. I don't know how many people are supposed to be in this class. 10, I think. 2, 4, 6, 8, 10. We have everybody. All right, good. So nobody that's actually in the class is missing anything. So it's fine. So if you happen to be watching on the internet, I'm sorry. I know I'm talking to no one, so, whatever. All right, we have a triangle that, when we extract it from its picture, looks like this. Are they touching in the middle? Yes. I drew this way too close to the top of the thing, but it's fine. And it shows us this and this. 8b says, if the measure of VR, which is this one, VR is 2.5, and QR is 2 meters, which is this one. Find the distance between QR and ST. So we want to, which would be this distance, right? This is a Q, and this is a T, and this is an S. An S. Okay. How do we go about it?
A squared plus B squared equals C squared.
That'll give us this one, absolutely.
And then we just have to multiply times 2.
We do, but we need to explain our reasoning, so we need to also say why we can do that, right?
Part S is parallel to line QT, and RQ and ST are perpendicular.
They are. How do you know they're parallel?
We proved that in the proof in part A.
Oh, in part A, you proved it. Gotcha.
Or we have that as a given. Yeah, we have that as a given in part A.
In part A,
Oh, yeah. You didn't need it, but because it's perpendicular, the same transversal, we'll give it to you. But yes. Yes. Okay, so Pythagorean theorem would say 2.5 squared plus 2 squared. No. What am I saying? Equals, because this is the hypotenuse. How do I know that's the hypotenuse?
Because
It's the longest. It's also the one across from the 90, right? Yeah. All those things. It's the angly looking one. It's the one that isn't perpendicular. All of those are true. Okay, so equals 2 squared plus the measure of QV squared. What's 2 squared?
4.
It is. I waited a second because I said, what is 2 squared? You answered that question, but in my brain I was thinking, what is 2.5 squared? And I was thinking, that's not right. Sometimes my brain and my mouth don't work together very well. Does that happen to y'all? Or am I just old and possibly ADHD'd? What's 2.5 squared?
6.25.
6.25. 2.5 plus 2.5 is 5, but squared it's not. Now what would I do? Subtract, and I would end up with the measure of QV squared equals 2.25. Then what would I do? Yeah, square root both sides. And I end up with the measure of QV is approximately equal to what? 1.5. 4 times 2 is 8, plus 1 is 9, so it's exactly 4.5, isn't it? Not approximately. Oh, excuse me, 1.5. I got it because I was thinking of something else. I told you, mouth, brain.
Now we just have to multiply times 2.
I got the 4 from 1/4. That's where the brain mouth broke. I do. Just have to multiply that times 2. And so 3 is the answer. 3 units if you want to have a better answer. Oh, just kidding. 3, just kidding. We need a better answer because it gives us the units. 3 meters. So Pythagorean theorem would be the reasoning for this part. The triangles are congruent because of what we proved in part A. Segment addition would give us that this is 3.
How did we, I did the proof in part A wrong. I know I did.
Because what?
Um, wait, no, I didn't. I said that angle R and angle S are congruent because it says that triangle VRS is isosceles.
No.
Can the base angles are congruent? And since those are straight up lines.
So, okay, so let me kind of scribble and make sure I'm following your logic, right? So, in the picture, we actually have this connected as well. And so, what angle are you talking about?
I'm saying, and since the base angles are,
No. I know, I'm hearing your justification. There's 2 angles there. You said angle R and angle S. What angles are you talking about?
so SRV and VSR are congruent.
SRV and VSR are congruent. Yes. This, because base angle is of an isosceles triangle. Yes.
And since that base, those are perpendicular lines, it says that those, it doesn't say anything about that, but logic in my brain says QRV and VST are the rest of that angle left over, and those 2 are congruent.
So, okay, so your proof is wrong and incomplete because to go the route you're talking about, you're going to need angle addition to be able to get to these angles. And then you're going to have to go and do some substitution stuff and whatever else to get there. So do we want to look at that proof? Yes. Okay, let's look at that proof. All right. So 8A, you know, I don't look at the camera often enough. So when I'm trying to grab a thumbnail real quick, it's usually just like some blurry nonsense. I need to smile more. I can have y'all come up and be like, when we finish the proof. If anybody wants to appear in the thumbnail, that would be the way to do it. Oh, so the given in this proof is a whole bunch of crap. This is 8A. The given says that QR and ST are perpendicular, right? And triangle VSR is isosceles. VSR is isoc. And has a base SR and QT with base SR. Base with base SR and QT is parallel to SR. QT is parallel to SR. And we're supposed to prove that the 2 triangles are congruent, the 2 side triangles. Okay, now what?
can say that angle VRS is congruent to angle VSR, who definition of isosceles triangle.
That's not in that triangle. That's VRS is right here.
VRS?
That's what you said. Oh, just kidding. Oh, yeah. We want to go that way. Yeah, that's fine. I thought we were going to try to go a different way, but that's fine. Sure, let's do it. Angle VRS. What did you say that's congruent to VSR? Is that what, or are you doing something else? Okay. Okay. It is congruent to angle VSR because base angles of isosceles triangle. True enough. So, put back what I erased. These ones congruent to that one, right? Great. Now what?
Then I said RVQ is congruent to VRS through alternate interior angles.
RVQ is congruent to VRS. Yes. Yeah.
And I did the same
On the other side. Sounds great. So angle RVQ is congruent to angle RVQ is going to VRS. VRS because alternate interior angles. And then same justification gives us angle SVT is congruent to angle VSR. Same justification. Got all kinds of congruent stuffs. Although that technically doesn't really say what I said it says. What that says really is that just this is congruent to that. We don't know that these are congruent to each other technically yet, right? That's where the substitution bit's going to come in.
Would you not mark them all the same because
We're about to.
S is congruent to VSR?
We're about to. But we haven't said that yet, but because we need substitution, then we're saying that, right? So we can say RVQ is congruent to SVT. RVQ is congruent to SVT because we substitute, well, no, I guess we can't quite say that yet, right? We gotta substitute one and then the other, right? We can substitute VSR right here, or transitive property really, because it's the same as this one. So angle RVQ is congruent to angle VSR because of the transitive property. Right? It's taking this one and putting it here because they're the same. That makes sense?
And that's the transitive?
Yes, because it's just A and B equals B and C equals A and B. I said this last time, if you put substitution there, I wouldn't count that wrong because it is kind of substitution as well. So, yeah, and then one more of the same, right? Because we can now say which ones are we trying to do? The RVQ. RVQ is the same as SVT because they're equal to the same thing. Angle RVQ is congruent to angle SVT. Again, by the transitive property. So that does what I was marking before, right? Where these are all the same. This is the same as that because it's the same as that, right? Now what? So if you jump straight to that, I wouldn't count it wrong. We do technically need one more step because we don't technically have angle Q is congruent to angle T.
It's marked. They're this way.
Yeah, it's marked that they're perpendicular, and they're both perpendicular. So we actually need two lines in there, really, because what does the fact that they're perpendicular tell us?
We need to say that they equal 90 degrees.
Yes.
But in the picture, it gives us the square.
Yeah, but it's
It gives you that they're perpendicular. There is a whole theory, well, it's postulate actually, I think, but that says that all right angles are congruent. Yeah? So
I just put that down.
all right angles are the same.
that's why it's a postulate, right? It's a no duh kind of a thing, yeah? Again, like if you were, like in this particular proof, if you were to jump straight from here to they're congruent by angle side, I probably wouldn't count off, honestly. I would probably, that's fine. That makes sense. But technically we need angle Q is right. And angle T is right. Because what? Definition of perpendicular. That's right.
Why isn't it?
And then angle Q is congruent to angle T. Because why? All right angles are congruent. I can see the joy in your faces right now. And now we can say that triangle RVQ is congruent to triangle STV.
Two whole lines to something that's on there.
Feels obnoxious.
It feels redundant. I'm efficiency. Come on.
Says the one who came here in a giant Ford.
I must be
Okay,
on
you know
my
what?
rock
Okay,
now.
it's
I only
efficient
got
because
four
it
steps.
loads.
You got 4 steps.
It
Nice.
transports all of the two
I
which is
feel rather strongly that there's probably another way to get there in this proof that might be
Is there a
shorter.
way that I was trying to do?
I don't know. I thought this was basically what you were trying to do. They used 8 steps in theirs, but they're not quite the same 8 steps. Oh, they also added that's so in our proof actually we would
Drive 2 Prius.
now it's in the picture, so this is in the picture, so I definitely wouldn't count off if you didn't put this, but they also said that RV is congruent to SV because of the definition of isosceles triangle.
Oh, so we need to do that too?
You would technically have to, like if you wanted like everything that you needed.
Because it's not in the given.
It's not in the given. All the given says is that it's isosceles.
Don't trust what you see.
Don't trust what you see. Well, and that's so we usually count, and so that's what I was saying is we count what's explicitly written in the picture as part of the given. And so like the picture has the tick marks. So do you need that? Do you not need? Probably not. Like the way we typically write things, you wouldn't really need
Would
that.
it be wrong to just put it in the given?
It wouldn't be. Like the way I go about doing stuff in there is if it's written explicitly, that's given, right? So yeah, just adding that into the given that those are congruent. That's fine.
This could be 2 lines shorter.
They do have all right angles are congruent. Went with isosceles angle VRS. This is VSR. It's because isosceles, the base angles isosceles. Interior, transitive property. So somehow we have an extra step that they don't have.
You wrote 2 different steps for transitive.
Yeah.
You use 4 and 5 for transitive.
But we needed 4 to get to 5. So we couldn't have put them in the same step, so,
Well, they went by basing.
well, so did we.
I mean, not that. What was the next thing after they were basing? What was that?
They did do same alternate interior angles that we did, and the transitive property. So I don't know what the extra step, or what we did that they didn't do. I don't know.
Did they do definition of perpendicular?
Yes, they did. Definition of perpendicular, did all right angles are congruent. Yeah, so I don't know. They do somehow only have one transitive property, TVS. TVS is congruent to QVR. So somehow they have this QVR, which is a different angle. Oh no, it's that same angle right there. QVR, what did I say? S?
You said TVS is congruent to QVR.
TVS is that's, yeah, same angles as what we put. So they don't have, but they do have that this is congruent. I don't know, it doesn't matter. Do we have any other questions on this lesson? The other proof was easy money. There was, right? We went through 24? So it wasn't easy money, and we should look at it.
Well, the proving it was easy. Figuring out how to prove it wasn't. I kept looking at the smaller triangles.
Oh, yeah. Sometimes when you have, shapes where it's got like nested triangles, you have to be able to break it apart and look at different stuff.
24, I didn't even think of, I mean, I tried.
I feel like I have this looks really familiar. I think I have a video about 24, I think. I'd have to go look through my stuff, but I think I do. I think I have a whole video on 24. Let me look real quick because I'm curious.
Yeah, we should do.
YouTube Studio.
I got 2 steps in.
What were your first 2 steps?
The given.
The given and
One step in, and then the second step was WY is congruent to WZ because of the definition of
Yeah.
weight.
you mean WX and W and
No, WY and QZ is what I meant.
That works, doesn't
Yeah,
it?
that should
Because
work.
definition of a
Midpoint is what I have.
The 2 lines are equal.
well, it says W is the midpoint of XY, so
But it also says that XY and XZ are congruent.
you're gonna have to probably use some substitution stuff to get there.
We're good.
Probably. I don't know. We'd have to look at it. Hold on. Let me look at this before we possibly do it again.
Last night, I thought this cost you like how much money was.
Good job. I could never prove it.
Actually, it was. Oh my gosh, that's so sad.
Will one of these be on the test?
I should dress up with a spelling test probably. Because I
What?
can't think of
One of
it.
these be on the test?
Quite possibly.
I guess it was 2
Geometry homework help.
My friend Gracie was the one.
Page 315, page 315, page 281. Nope. I have page 281, number 19, which is from this lesson, but not this one. I guess not. Maybe I have it. Do I do one that looks like that in one of the videos or something? Y'all remember a triangle that's kind of like that in a video? I swear I've made a video of this problem, or maybe I just remember helping people with this problem before. I don't know. Okay. It's a fun problem. It's good.
I won't lie to you, I didn't mess with it.
I saw a proof, got scared, and backed up.
Well, it was late. I was like, I'm tired.
I didn't
don't-
feel like there was enough. I couldn't find
I'm judging you from off. You're right. It wasn't even funny. It was just weird. I don't know how to hide my textbook. No, you should have stapled the notes. I would cry. All of my notes got stapled for you, but none of my notes.
And we're supposed to prove something. WZ is congruent to QY. W, so this guy. Okay. What now?
Can we say that XY is congruent to QZ, the definition of midpoint? Because
I don't think that's what you meant to say, but
I don't know if that's the right justification.
W, A, and QZ.
yeah,
But,
you're trying to say XW and XQ, right?
WY and QZ.
Okay, sure. That, yeah, same. No, you can't. Because what would let us say that?
We have the big sides are equal, and we know W is halfway. so
True.
why can't we-
So we can't say that in one step. Because what theorem would let us say that two midpoints, whatever, are, I mean, there's no way we can just say that in one step.
You came up with it.
It's like, that's like not possible. Because we don't even know.
Because W is halfway through XY.
And XY is congruent to XZ according to given.
Yeah. So we need like two steps to say that, right? Segment, do they use segment addition? Let me see. We're curious. Ugh, I read a friggin' paragraph proof. I have to figure out what the heck is happening. W is the midpoint. We know that that's congruent to that. The midpoint of that. Yeah, yeah. That's, yeah. Yeah, I think that's the way we're going to have to go, right? So, backing up from what y'all are wanting to say, because that's something that we can say eventually, right? So, backing up from that, what can we say straight from the given without going anywhere else? What does the fact that W is the midpoint tell us? Yeah. So let's add that, right? The measure of XW equals the measure of WY and the measure of XQ equals the measure of QZ. Because why?
Definition of midpoint.
Definition of midpoint. Okay, so we said this is congruent to this, and we said this is congruent to this. Great, grand, glorious. Now what?
Isn't X, Y congruent to X,
Yes,
so why didn't we write it?
we did, right here. Oh, why didn't I draw it on the picture? Because it was a two-segment thing. It was going to be more confusing to look at. But you could add like this is congruent to this so that you remember what's happening. You could certainly do that. Okay, what now? Y'all are headed in the right direction. Like, you know where you need to go. We just need to like go there through means that we have. Like, I don't know. I thought we could just go there. I thought we could just go to the store. I didn't think we had to make 5 other stops. Mom, I'm ready to go home. We can say that this plus this equals that, right? And that would be useful because, see, we have this, we have that, and we have something about that, right?
So do we need to say wy plus wx equals xy?
And then
And then substitute in and say wy
Yes.
plus wx
Yes.
equals xz, and then say wy.
Yes. Yes. All of that. Yeah. So the measure of xw plus the measure of wy equals the measure of xy and the other side, right? The measure of xq plus the measure of qz equals the measure of the big one. It's about this time in the year where I need to like yell some words real quick. And let me finish writing these lines so I don't forget what I'm doing. This is because of segment addition, right? If you are in the habit of, I start doing a proof, we start talking about proof, things start happening, and you zone out. Stop it! Put your brain back on. If you get confused, say something. If you're not doing that, then I'm not yelling at you. If you are doing that, stop it. You're missing the whole point of this class. The whole point of this class is to get you to think and to learn how to use these thinkings. Yeah? It's not about segment addition. Who the heck cares? You're not going to be a mathematician. None of you are. Probably. I mean, you might be, but probably not. Some of you might be engineers. I bet none of you become a mathematician in your life. Possibly theoretical physics. I mean, some of you might. Could happen. It's not because you can't. Just because I don't think any of you really want to do that. So who the heck cares about segment addition? That's not the point, yeah?
My dream is to be homeless.
Yeah, you've said that before.
What?
Okay, so we said this plus this equals this plus this. Now what can we say?
the xy and xz, since they're congruent, there's a transitive property to make them both.
Substitution, actually, but
Wait, what?
I.
Can we not just say that
Same.
xw plus wy equals xq plus qz through the transitive, because we already have that the big lines are equal and that the little lines plus the little lines equal the big lines?
we don't quite technically. But yes, it's one thing that you're not adding in there. And then yes, we can. What lets me say that simple thing?
Definition of
It's not given. That's not given.
Oh, the definition of congruent.
Definition of congruent segments. True facts.
Oh, I should write that.
Great. Isn't it cute? Now we can do exactly what you just said. Because we have that these are congruent. Well, we can't really do quite what you just said. Because we have to replace it first. And then we could say this is that. What are we even trying to do? What are we trying to prove? WY and QZ that we're trying to do?
no, well, right now we're trying to prove that, but at the end we want.
Oh, these diagonals. So we need to get a couple triangles. Okay, so we need to get a couple triangles are congruent. Is ultimately what we're trying to get to, right? Which triangles contain those things? There's these big ones here, and then there's these ones here, right?
I got
WZY and QY. Yeah, those. So there's two different sets of triangles that include them. There's these ones, which what you're talking about, and then there's also these bigger ones, these bigger chunks that also contain those. So you could, whoa, mother of pearls. You could go either way. Trying to see if it would be easier. It'd be funny if we didn't really need like half the things we're doing.
We have to for both of them because whether it's the bottom or the top of them, we have to say that the little half is congruent to the big half.
You have to get
It's just which half we're saying.
Little half is congruent to the big half.
Like for the really big triangles,
Uh-huh.
we need XW for the right side. and
Oh yeah, we'd have to go this route either way. Yeah.
which one we have to use.
Yeah. But do we though? Yeah, because we'd have to get
You
'Cause,
know,
let's
the
see.
little triangle-
side angle,
These segments
side
where
or
you have to make the triangles.
Right.
or angle,
No, but that's what I was trying to.
side.
But there's no way of
I don't know where. I don't even know if we can get to the big triangles.
We could say that X or YX and ZX and QX and WX and then use reflexive on angle X.
Yeah, but that only is going to give us side angle on the big triangle, right? Where's another? Where's?
The extra long side. and-
Oh, yeah. Because you could get side. Okay, yeah. You're right.
But we have to have.
No matter what, we're going to have some version of this. Yeah. Okay. So we can say that the measure of XW plus the measure of WY equals the measure of XZ. Because why? Substitution.
Wait, did we substitute anything?
Yeah, we did.
From step.
We changed this line to have this one there. So now we're going to be able to say that this is this.
So what I tried to do for my second step,
Not yet.
or not yet?
Not yet.
Oh my gosh.
The measure of XW plus the measure of WY equals the measure of XQ plus the measure of QZ, because transitive property or substitution. Now what?
Now can we say all the halves are equal?
How?
I'm not sure.
If
They're equal and those are equal and those are equal,
so we can do another substitution, right?
yeah.
Get some stuff that matches. Which way do we want to go? Big triangles or little triangles? If you vote big triangles, raise your hand. If you vote little triangles, raise your hand.
What?
Okay, big triangles it is. Even though you went for little triangles, we're going some other way. Okay, so we want to keep XW and XQ in this thing. We want this to be an XW and this to be an XQ, right?
I'm just getting
Where are you confused, girl? Have you shut your brain off and like confused yourself on purpose, or are you trying to look at yours and compare it and that's confusing you? Don't do that.
Yes, that's what I'm doing.
So stop doing that. Make sure you understand this,
Because,
who knows whether that's right or not at this point, right?
well, I'm trying to, I just,
What is step 6 about?
I don't think.
Step
mine is
6.
wrong.
Step 6 took this and set it equal to this because they are equal to the same thing.
Mine is wrong. I just
That
don't.
plus that.
I don't understand.
It's
why-
probably wrong.
This plus
Okay.
this.
It's because
If it doesn't have all this, it's not complete for sure.
No way.
Aneurysms
I
are
still
bad.
don't
Means
understand why
is-
somebody
I
else
guess I'm
hasn't
sure,
made
yeah.
something that said because the wholes are equal to halves.
You could write that as a if you were reinventing Euclid for some stupid reason or whatever, then you could write a theorem that did that, and then later, and you'd have to prove that it works always, right? And then you could use that theorem in the future, which is how a lot because that's how theorems get made from postulates, right? You start with undefined terms. You start with Euclid's beginning, and it's like, okay, well, if this is true, then this is always true. If that's true, then this is always true. And this is true, then that's always true. And that's what you're going for. You know, when you're doing a proof, is like any triangle that looks like this is going to be true, right? I mean, and that's kind of what you're going. And then you can check all this into another notebook somewhere else that has that proof, and then you can just use Ries's theorem 5.1, you know, or whatever, right? I mean, that is what you would do. Anyway, now what should we say?
Can we say that WX?
No. Go ahead, maybe, I don't know.
WX because of substitution, since we have that the wholes of the combined halves are equal.
No,
No?
there's nothing really that gets us there yet.
Oh, wait, but how do we get past this?
It's just a triangle.
Easy money. Okay, so let me do that. So I took WY and I turned it into XW, and I let QZ and turned it into XQ. What lets us do that?
Higher up we have.
Yeah, yes. I have this, right? So I can substitute one for the other, right? We're about to enter a very brief algebra proof, right?
Wait,
Because what can we do now?
did you say XW plus the measure of XW?
I did. Because
higher up we have XW.
because as WY equals XW. So I can substitute XW in for it. And which is what we want if we're going for the big triangles, right? Because I want these. And so I need these in, so I substituted that way instead of the other way because these are the ones that I want to keep, right? The other one, I don't care about these anymore because we're going for the big triangle, right? Okay, so now what can I say? Because simple algebra. You do, it just looks like a lot of letters, look.
Can't we just say XW equals XQ? I just don't know how.
Almost. Almost. What can I do with this?
Just X to it.
2x.
Bruh. No, there's numbers.
No, there's numbers. Wait, what? No. Don't give me numbers back.
What?
Oops, I left off a 2, yeah?
It's having,
This is
I know. What are you talking about?
this is making me ninth or whatever grade Jacob having.
Okay, we're almost there, and then I'm going to say leave. What lets us do that? Simplification. Great, simplify.
I'm
Act-
gonna have nightmares about this.
It's okay, Ellen. You can get your warrior cat.
I mean, I'm fine with it. It's just, if it's on the test.
Wait, would we just simplify again to get?
It's not called simplify, but yes. We can just say that. Is that what you were going to?
Yeah, because we just divided both sides by.
Yeah, division property of equality. That's what we did. Yeah.
Much I bully my friends.
Yeah, yeah. this-
Division property of equality.
For no reason.
No, now we're all the way back in unit 2.
Great. So now we just said that this is congruent to this. We don't necessarily have to finish because the rest is pretty hop, skip, and a jump, right? We've got this is congruent to this. We've got an angle here, and we already know that those are equal. So once we do reflexive property of angle x, we've got side, angle, side. We've got the triangles are congruent. If the triangles are congruent, then the sides are congruent by CPCTC, and we're done. If you want, which part is what?
Q at Y and WC are what we're trying for.
Right. So what we're, with like a couple more steps, we're about to prove that this triangle is congruent to this triangle.
And then
Oh.
for CPCTC, we can say those sides are.
Never mind, I was in the wrong planet this whole time.
Okay, welcome back.